Here's a circle that solves any two-dimensional stress problem on the PE exam. One drawing, principal stresses, maximum shear, every rotation of the element. Otto Mohr published it in 1882, and engineers still draw it today. Start with an infinitesimal element of material. Each face carries a normal stress sigma and a shear stress tau. Here, sigma x equals 80 MPa, sigma y equals 40, and tau xy equals 30. Rotate the element and those numbers all change. Mohr's idea: take the stresses on each face and plot them on a new plane. Sigma on the horizontal axis, tau on the vertical. The right face becomes point X. The top face, with the opposite shear sign, becomes point Y. Mohr's discovery in 1882 connect X and Y. That line is the diameter of a circle, and every rotation of the original element, every face you could possibly cut, produces a point that lies exactly on this one circle. The circle's center sits at sigma average, which is the mean of sigma x and sigma y, 60 in our case. The radius r is the square root of the difference over 2 squared plus tau I txy squared, about 36.1. Two numbers, one circle. Principal stresses lie where the circle crosses the sigma axis, the orientations where shear stress vanishes. Sigma 1 equals sigma average plus r, 96.1. Sigma 2 equals sigma average minus r, 23.9. Those are the eigenvalues of the stress tensor. The maximum shear is the radius itself, at the top and bottom of the circle, where sigma equals sigma average. Tau max equals plus or minus 36.1. The corresponding physical planes sit 45 degrees from the principal directions. The angles double. Rotate the element 30 degrees in physical space, and the point walks 60 degrees around the circle. The 10th scaling comes straight from the cos 2 theta and sine 2 theta in the transformation equations. In 3 dimensions, you draw 3 more circles, one for each pair of principal stresses. All physically admissible stresses live in the region bounded by the outer sigma 1 to sigma 3 circle, outside the 2 smaller ones. The outer circle's radius is the absolute maximum shear. FEA replaced the hand calculations decades ago, but Mohr's circle is still on every PE exam, still the fastest sanity check for FEA output, and still the cleanest way to picture the eigenvalue structure of a symmetric stress tensor. A century and a half later, still the standard tool.